Good morning, students. Hello, or good evening, or good afternoon. I don't know when you guys are watching this, but welcome back to math class. I know it's been a interesting past couple of weeks, but hopefully I can kind of distract you off of whatever you guys have been thinking about and kind of steer you back into some math here so we can get kind of as close to normal as we can. I'm sure a lot of you guys miss school, as do I. I miss being there with you guys. So hopefully you guys are doing well, staying safe, and I will get to see you guys soon. Today, we're going to jump right into where we left off last with CPM, with Chapter 9, 9.2.1, and we are now working with triangles, and I'm going back to triangles, and we're going to work with some squares today. And we're going to see if we can use squares to actually make a triangle, specifically the sides of a square. Okay, so our lesson today is about side lengths of squares and if they can make triangles or not. Okay, so our objective will be to compare the side lengths of squares to see what combination of side lengths will make triangles. You guys are going to focus on those that do make or can make the triangles, and see if you can identify any particular patterns or combinations that can make a right angle, or a right triangle, an acute triangle, or an obtuse triangle. Okay, so we're just gonna jump right into here. I'll go ahead and read this first paragraph to you guys. It says, triangles are made of three sides, but can any three lengths make a triangle? Is it possible to predict what kind of triangle, obtuse, acute, or right, three side lengths will make? Today you will you will investigate these questions with your team. Okay. So 9-51 says, is it a triangle? When do three lengths form a triangle? Are there special patterns in lengths that always make obtuse triangles? To investigate these questions, you and your study team, which will be me, will build triangles and look for patterns that will allow you to predict what kind of triangles three lengths will make. So as we do the problems today, there are a few printable resources that you're going to need to do it. I do not expect you guys to go and print these out. In fact, I recommend that you just follow along with my video and just kind of pay close attention to it, rewind it, pause it, go back and see if it makes more sense the second time or third time around if it doesn't make sense to you the first time around. Okay. Again, do not print any resources. In the future lessons, I will probably have you do some problems on your own, but today, kind of just bear with me, follow along, and it should make sense. So some questions that we can ask are, how can we organize our data? What other combinations can we make? And what do we expect will happen? Okay, so we have resource pages here that I've already prepared, and I'm going to go ahead and pause the video, and I'll show you a second part to this where I'm actually using the resource pages. Alright guys, so for this part of the lesson, basically we're going to be answering this question from the first resource page of 9.2.1a, and it's asking how many different triangles can you make using these squares. And essentially we have different shapes and different side lengths here in regards to squares and different sizes. So we have something that is 13 squared. If you notice, each side will, if you count it, it would be 13 by 13, which 13 times 13 would equal 169, right? This one right here is a smaller one. This is 8 squared. That means one side is 8 units long, the other side is 8 units long, and 8 squared, 8 times 8 is 64. That's why these are called squares, because the side lengths are the same, and when you multiply and get the area, they will give you this number. Okay, so we've got a lot of different sizes here. They go as small as 3. We have a 4 side, square with a side of 4, a square with a side of 5, a square with a side of 6, 8, 10, 12, and 13. Okay, so you can't see the 10, there's the 10. And essentially what we're going to do is I'm going to try to pick some random squares and try to make a triangle out of the side lengths so that they can reach each other. Kind of like this right here. You see this diagram? You got 3 different squares and they all connected the vertices, the corners of the squares, to make a triangle. Okay, so I'm just going to go ahead and pick a random one right now. If I connected these, does it make a triangle? Yes, it does. Right? So this is a 10, 12, and 13 for the side length. So what I'm going to do is I'm just going to go ahead and record my data that I found here into this table that's been provided to me. Okay, so this table, it says I'm going to fill this out just one by one. The length of the smallest side, the small side, is 10. The length of the medium side is 12, and the largest side here is 13. Okay, so I've got a 10, a 12, and a 13. So the area of the small square is 10 times 10 is 100. Area of the medium square is 12 times 12 is 144. The area of the large square, 13 squared, is 169. So I'm just going to go ahead and fill that in at this point. And I'm just going to follow into the next table. So again, if you guys were actually in groups in class, I'd make you do this right now. Small square, small area plus the medium area, 100 plus 144 is 244. Okay, and then is it equal to, is it greater than, or is it less than the large area? So the large area is 169. 244 is greater than 169. Because of this, we're going to go ahead and call this an acute triangle. So if you guys remember your vocabulary, acute triangle is where all the angles in a triangle are less than 90 degrees. Okay, obtuse means greater than 90 degrees. Okay, that's when one angle within that triangle is greater than 90 degrees. But here, all 3 angles are going to be less than 90 degrees. And then our third type of triangle, as you are familiar with, is a right angle, where one of those angles is going to be 90 degrees. And essentially, I'm just going to go ahead and play with some more. So here is a 10, 8, and a 6. All right. So here's a 10, an 8, 6, and a 10. Let's see if I can make a right triangle out of this. And I can, right? So again, I'm going to go back to my table. I'm going to fill in my smallest side length is 6, medium is 8, third one, the largest one, is 10. 6 squared is 36, 8 squared is 64, 10 squared is 100. So the small area plus my medium area, 36 plus 64 is 100. And then my large area over here is also 100. So 100 is equal to 100. So it's a special, very special situation that we have here. Again, if this were class, I'd make you guys kind of talk this through, see what you notice, see what stands out, see if you could detect a particular pattern here. But for right now, I'm going to tell you this is a right triangle. So if you look at the diagram here, this will make a right triangle, okay? Because that would be the 90-degree corner right there, okay? Let's just do another one. How about 13, 4, and 10? Let's see if that would work. Ooh, I don't know if that's gonna work. You guys think that'll reach? Oh, it's pretty close. Oh, looks like that one will reach. Okay, so this one here, the smallest side is 4, medium side is 10, the largest side is 13. All right, so 4 squared is 16, 10 squared is 100, 13 squared is 169. I'm going to add my small and medium area. 100 plus 16 is 116, and my large area is 169. 116 is less than 169. Now, if the small and the medium area was greater than the large area, we call that acute. If the small and the medium, the sum of the small and the medium area equals the large area, That's right. Now the small and medium area is less than the large area. What do you guys think that's going to be called? That's right. It is an obtuse triangle. Okay, because if you look at this one, this angle right here is greater than 90 degrees. Okay, so again, I don't know if you were able to see that on the video, but there is the triangle. Okay, let's do another one. Let's do one more here. How about 12, 5, and 4? What type of triangle is this going to make? Well, will it make a triangle? Let's see. What if I did that? You guys think it'll reach? Oh, no, it's not long enough, right? Not long enough. So I think of it as like a T-Rex trying to clap his hands. His arms are too short, it won't reach. That vertex and that vertex aren't going to be able to touch each other. So I'll go ahead and record this on my table. My smallest side is 4, medium side is 5, large side is 12. If I were to square 4, I get 16, square 5, I get 25, square 12, I get 144. Small plus medium area equals 16 plus 25 is 41, and my large area is 144. So now, you guys are thinking, well, we just talked about this, Mr. Tran. You said that if the sum of the small and medium area is now less than the large area, that would be obtuse, like it is right here, right? Actually, that's only the case if you're able to create a triangle. So let's go back to the diagram here. Were we able to create a triangle? No, we weren't, right? So this one is, we're just gonna write not a triangle, okay? It wouldn't be an obtuse triangle because it's not a triangle, so we can't call it a triangle, right? Basically, the idea, the purpose of this is for you guys to just play around and find other different combinations of what you can make, right? Here's one with 6, 10, 6, and a 3. Let's see if we can do another one. And as you can see here, this one's going to be close. You guys think it'll make a triangle? Well, one way to find out. If I know one side is 6 right here, another side is 3 right there, 6 plus 3 equals 9. That even if I put these two squares up against the side of the 10 square, it's not long enough to reach. So again, that would not be a triangle, right? And so we keep doing this until we find as many combinations as we can, and you come up with something like this. So this is one of the final results. There are obviously more options here for obtuse triangle, because it says all other side combinations that could make a triangle. But these are the important ones. So let's take a look at these 3 for the right triangle. The first 3 right here, we've got 3, 4, 5, 5, 12, 13, 6, 8, and 10. You're gonna realize down the line that those are very special triangles, okay? When we talk about right triangles and side lengths, those are special right triangles where the longest side is going to be what we call a hypotenuse, and we'll talk about that down the line. But these right here, these next set of 3 triangles are acute triangles. We have 6, 12, 13, 8, 10, 12, 8, 12, 13. Okay, so I will post this on my haiku page, so if you guys want to download this, you can. Yeah, that's it for now. We'll get back to the lesson. So going back to 9-52, after watching those, me working with those squares and trying to create triangles, this question is asking basically, what do you notice? What do you notice about how the 3 sides compare to each other? How are these sets of 3 side lengths that did not form the triangles different from the sets of side lengths that did form the triangles? Okay, be as specific as you can when answering this. And then when your team has reached a conclusion, copy and complete the 2 statements below in your learning log, title it Triangle Inequality, and include today's example. So it says 3 sides will not make a triangle if, and then you can draw your conclusion there. Then you can say 3 sides will make a triangle if, and you can write your conclusions there as well. Okay, so right now would be a great time to pause and just kind of complete those 2 sentences right there, and see what you notice. Go ahead and jot that down. Okay, and you should have something like this. I forgot to ask you to pause it, so if you didn't pause it, no worries. Here it is. 3 side lengths will not make a triangle if the vertices of the 2 smaller squares can't reach each other. Those vertices are the corners, right? The corners can't reach each other. Like I said, the dinosaur, the T-Rex arms cannot give itself a high five, then it's not going to form a triangle. The 3 sides will make a triangle if the vertices of the 2 smaller squares can reach each other. Emphasis on can. Okay? All right, let's go ahead and move on to the next question. Scroll down here, 9-53. 9-53 says, look at the data that you collected for the acute, obtuse, and right triangles. What patterns do you see between the sum of the areas of the 2 smaller squares and the area of the largest square that formed the triangles in each row? Copy and complete the sentence starters below in your learning log to summarize the patterns that you see. Title the entry Triangle Side Length Patterns and include some examples along with the date. Okay, so go ahead and pause the video right now and take a second to, basically this is what I explain in the other portion of the video when I work with the squares. Okay, go ahead and finish these sentence starters here, these 3. I'd pause it for about a couple minutes and then come back and we'll talk about your results. Okay, let's go over the results here. The first sentence says, if 3 squares have sides that make an acute triangle, again, emphasis on now we're talking about an acute triangle, then the sum of the squares of the area of the 2 small squares, so if I add up the 2 small squares, the area are greater than the area of the large square. Okay, and we talked about that in the video. If 3 squares have sides that make an obtuse triangle now, okay, so let's focus on obtuse triangle. Remember that triangle will be greater, it has an angle greater than 90 degrees. The obtuse triangle, then the sum of the areas of the 2 small squares are less than the area of the large square. Okay, and then the last one here, if the 3 squares have sides that make a right triangle, emphasis on right triangle, then the sum of the areas of the 2 small squares are equal to the area of the large square. Okay, so those are very important things to just keep in mind as we move forward. Good information for you guys to know. Okay, let's go ahead and move on to the next problem. 9-54 says, use the patterns you found to predict whether each set of side lengths below will form a triangle. If a set will form a triangle, state whether the triangle will be acute, obtuse, or right. Then justify your conclusion. Okay, so you've got 6 examples here that I want you guys to actually now try out on your own. Okay, so do what we've been doing. See if you guys can determine if these triangles are going to be acute, or right, or obtuse. Okay, or if they can even make a triangle. If they're a T-Rex and they can't have the vertices touch each other. Okay, so let's do the first one. I'm going to do one for you, and then you guys can do the rest. Okay, so what we want to do is we want to determine which one is the largest side. Okay, so these are all 3 squares. There's a square with a 5 side length, square with a 6 side length, square with a 7 centimeter side length. Okay, so obviously the biggest one is going to be right there, 7. So we know that if I square that small one, add the square of the medium one, we've got to take a look at our results compared to the square of the large one. Okay, so let's go ahead and try this. Okay, 5 squared is going to be 25, plus 6 squared is going to be 36, and then 7 squared is going to be 49. Okay, so I'm going to add 25 plus 36, and I have to ask myself, is it greater than, less than, or equal to 49? Okay, 25 plus 36 is 61, and 61 is greater than 49. So going to back to what we know, the sum of the two small sides is actually greater than the largest side, the area of the largest side, then that's going to be an acute triangle. Okay, so I will go ahead and pause it at this point, and you guys tried the rest of the 5 problems. All right, welcome back. Did you guys take a look at problem B? That's probably the one you did right after I did A for you. At first glance, if we added 4 plus 121 and got 125, it is less than 225. And our first assumption is that we're going to say that it's obtuse, right? Because the sum of the two smaller squares is less than the large one. When that happens, it is obtuse. However, those two side lengths, and we're looking at side length of 2, side length of 11. If we lined up a 2 and an 11, we added those up, that's going to be 13. 13 isn't going to be long enough to reach 15, right? So those two vertices aren't going to be able to reach each other, okay? Because 2 plus 11 is less than 15, so therefore it's not going to be a triangle, right? So those are tricky. You think it's going to be an obtuse triangle? This is actually not a triangle, okay? Let's look at question C. You're going to get obtuse triangle. We know that that will work because when I add 10 plus 15, it's actually going to be 25, and 25 is bigger than 20. So 10 and 15, when you add them up and they're longer than that the side of the third square, it's going to be able to make a triangle. And when that happens, we have another obtuse triangle here. Move on to problem D. Notice 676 equals 676, so therefore it is a right triangle. Those are very special. We don't get those triangles very often. Okay, and then for problem E, you notice I drew a purple dinosaur there. I don't know if you guys are familiar with Barney or not, the purple dinosaur. But I'm not even going to attempt it, because I know if I line up a side length of 1 with a side length of 3, that's 1 plus 3 is 4. It's not even going to be close to reaching 9. So there's no way. That's like super T-Rex. There's no way those two vertices are going to be able to touch each other. Okay? I know you guys like my artwork. Pretty impressive. And then the last one, F, 104 is less than 121, and therefore that is an obtuse triangle. Okay? So that wraps up for today's lesson. If you guys want to do 9-55 on your own as a challenge, I definitely say go for it. You are going to take notes tonight or today as part of your assignment. You do have methods and meanings. I will check your notebooks when we come back, though, so just make sure, if you guys want to do it on a separate piece of paper, go for it. It will let me grade them much faster when you guys do come back. And then tomorrow, you guys are going to be doing your homework problems that are posted on my weekly agenda page, on my Haiku page. And you can do your repetitions and your summaries on Friday. So every Friday, I'm not going to have new work for you. You're just going to go back and do repetitions on your notes and then do your summaries as well. So that's not going to take you long at all, right? You're going to get 2 lessons a week, basically, instead of the usual 4 or 5 that we give in class. So if you guys want to save your methods and meanings till Friday, you can feel free to do that, or you can do them today, right now, right? It's up to you, but you guys aren't going to hear from me for another couple of days on video. To my next lesson, I will be posting other updates daily. If you have questions, as always, feel free to email me. I hope you guys are doing well. Take care and stay safe and clean out there, guys. I will hope to see you soon. See ya.